other sessions. Take it away, Kit.
Oh, cool. First of all, everyone submitted, right? Project 1? Please. How much time do you guys think spend on it? I just want to. Yeah. Many hours? Okay, that's.
Per person?
Huh?
Per person altogether?
Let's say per person. I'm just curious. 25 hours. Okay.
Per person.
More than the suggestion. You're thinking you should have done more work. It's not a competition. It's okay.
Okay. Well, regardless, I hope it went well. I saw many of you work really hard, so I am keen to see. I'm gonna start marking today, so we'll see how it goes. To my knowledge, 2 groups in here have already been marked because I didn't mark them. But I'm start marking today, and I'm very keen to see. In terms of the major project, who has read the major project? Has anyone read the major project? Oh, cool. That's more hands than I thought. Alright. Cool. A new addition to the major project is the camera, and I want to show you some things the camera can do today. So, I don't have a Raspberry camera like you do, because I'm not using a pedal board, but I do have my own separate camera. This is an Intel RealSense camera. If I could marry a camera, this is probably the one I would choose. I think I have a backup one. You don't have a camera you would marry?
Oh, yeah.
This is another camera. This is a D415. Used it for a bit. It's pretty good. Okay, so let me show you what we can do with the camera first. So this is my specific camera, so you probably can't do this, but look at that. That's you guys. Oh, we can do RGB. Let's go to 2D. There you are. Alright, has an IMU as well, so I think it's a pretty good camera. What's better with this is it has a ROS wrapper as well, which is great because what are you doing? It has a ROS wrapper as well, and let me just build that. It's good that it has a ROS wrapper because you'll be dealing with ROS images as well in your major project. Don't mind all the packages. That's my thesis packages. It normally wouldn't take this long. I just have a lot of things on there. There we go. Alright. Source level bash. Cool. So my camera, I launch a different way. Your turtleboard camera will be different. I'm not going to go through how to connect to your camera. You should already know by now, and if you don't, it's on the E-Robotics manual, I think that's called. Yeah, the turtleboard guide. It's called Raspberry Can Note or something. What was it called? Yeah. So I have a ROS core running now, and my ROS node for the camera has launched. If I zoom, let's zoom in a little. Alright. If I do a ROS node list, whoops. I can see my camera node. It's the first one, camera RealSense 2 camera. And if I do a ROS topic list, there's going to be a lot, but right now we're just interested in the image topic. So we're going to be looking at camera, color, image raw. Alright, if we wanted to visualize this, we can do a ROS run, Arvis, bring up Arvis, and then you go add, go by topic, image, and then we get the feed again. There you are. Alright. So that's cool and all, but how about what if we wanted to do things with this image feed, right? Specifically doing the vision stuff. And that's where OpenCV comes in. How many of you have experience with OpenCV? In Python? Okay. And then I'll take that as like a half-half. Okay. Yeah. Admittedly, I have more Python experience with OpenCV than C++ as well. But as Don said in his lecture, we're now superheroes, so we can use the C++ version. And it's so much cooler than the Python version. Anyways, so let's go through some theory first. If I bring up my internet browser, and then I search up CV Bridge. CV Bridge is an important concept that you have to know if you want to work with ROS images and OpenCV images. Basically, ROS images is one data type, CV image is one data type, and CV Bridge is, well, a bridge. It converts ROS images to OpenCV images and the other way around, right? You can import it like any other ROS module, so let's see if we can do that. So first of all, let's have a look at our VS Code. So I already created a package called camera demo. I'm not going to go through how to do that. Code. Cool. One thing you might need to be careful with is with your CMake list this time. Your CMake list defines how your project will be compiled. And with OpenCV, there's different flags you need to account for. So make sure you change your CMake list. I'm not going to go through the CMake list stuff, but I will go through the CPP stuff. So let's just say we want to bring up our image feed. And let's zoom in a little. Maybe not that much. I can't zoom back out. Help. Cool. Anyways, so I have ROS imported. These are OpenCV header files that you need to import for basic image processing, image reading, and viewing the images. Not going to go through them either. Feel free to research them if you want. This is the package we're after, CV Bridge. So this does the conversion between ROS images and OpenCV. Aruco, we'll come back to that in a bit. So basically all I'm doing here is creating a class and letting it run, right? My class is called detector. I have a constructor, and then I have a callback. The main reason I have a callback is we want to subscribe to the image topic that we're receiving from our camera. Remember in our ROS topic list, there was a image topic, right? That's where your images are being sent, so we want to subscribe to it. So I already have my node handle, I got my subscriber. So in the constructor, you probably want to start subscribing to the image topic. So it's going to be underscore nh.subscribe. So if at any point you don't understand what's going on, just let me know, because I'm heavily improvising this. There's a chance I forgot to mention something. That's the syntax for a subscriber. All I'm doing is subscribing to this topic, and then whenever an image is received, I go to this function. Alright. I got my prototype here. For a sanity check, let's say whenever we get an image, we're just going to say image incoming. Alright, we're not going to do any viewing right now. We're just going to say we're receiving an image. So let's go back here. There's going to be a lot of cacking building. It's going to be some time wasted. So I hope you can bear with me. So in the meantime, whilst I'm building, if you have any questions, let me know.
Yeah. What's with all the other topics like the compress and all that? Do you ever use that?
I personally have never used compress. Do you use compress at all, Don? No. They're like the NPCs in the game. You don't really care about them. I have used IMU before, so that's good. Diagnosis is great for debugging, but the rest I really don't use. Maybe extrinsics. Okay, I also set up my CMake list so that I have an executable called demo. So my package is camera demo, my executable is demo. Image income, right? Nothing special? Do you have a question? No? Okay.
You get it.
Okay, alright. So now let's actually create our bridge. Alright. So the CV bridge is literally just called CV bridge. And then within that namespace, we have a thing called CV image pointer. Basically, this is a pointer to your image that will be converted. I'm just going to call it CV pointer. I don't like that. Okay. So we first have to see if we can actually convert it. So in the try block, I hope everyone knows what. Does everyone not know what a try block is? Yes, it's the same as the Python try. I think in Java it's a separate word. I'm not sure. Anyways, yeah. So we take the pointer that we just defined, and then to actually convert it, we have a function in the namespace called toCVCopy. Right? We take in the message that's incoming, so that's from the camera topic. So message, and then the syntax here is sensor messages, image encodings, BGR to BGR8. Yeah, I don't know this off by heart. You can easily Google this. You don't have to know this off by heart. But what it does is saying what color space the image will be encoded in. Fun fact, OpenCV does not do RGB by default. It does BGR. Why? I don't know. It's just like MATLAB doing arrays from 1. Sometimes people are sociopathic. So every time you want to deal with RGB, you have to convert it to RGB. But the default is BGR, so that's what I'm going to keep it as. Okay. So that's the only thing we have to do in the try block. Catch. What did I do catch here? CV bridge. So every time your try doesn't work, you have an exception message. You can either print that exception message or just print anything. It's good practice to print it out, but I forgot the syntax, so I'm just gonna print error for now. You should be better than me and actually print out the exception. Cool. So that's the try and catch block. Let's just draw a circle onto the image to know that we can actually manipulate the image. To draw a circle, it's CV circle. And to access the image that we've just converted, you use your dereference. Sorry, you damn, I forgot the member variable. Yeah, the arrow operator. Whichever coordinate you want to print it at. I'm going to do it at 50-50, so it's going to be at the top left. And then what color you want to put it. 10 is the thickness. So it should draw a red circle because I said CVRGB and then 25500. So to show an image in OpenCV, it's CV imshow. Hope that makes sense. The first argument is what you're going to name your window. I'm just going to name it kids window. And then you specify the image that you're going to display, which is, again, CV pointer, arrow, and then image. So image is a member variable of the CV pointer struct. And then because it shows frame by frame, you have to specify when it goes to the next frame. There's a function called CV wait key, which just specifies how much time in milliseconds before you go on to the next frame. So if I put 1 here, it's going to be 1 millisecond before I go to the next frame. Let's hope this compiles. Whilst I build, Any questions so far?
When you put in the try catch, what are you expecting to go wrong?
Maybe there's no image received.
Right.
Or maybe it's not in like the correct color space or encoding. And even if you can't think of anything, what's that law? Murphy's law? Something will always go wrong? Yeah. That one. Cool. It compiled. Yeah, we got the image. And there's a circle right about there. Right? So that just shows that we can like manipulate images. So OpenCV, you can draw lines, you can draw circles, whatever you want. So let's. It is technically red. It's just that the projector sucks. If you want a better projector, feel free to leave it in the unit of study survey. Because I do. Let's end this. So that's how you display.
Jobs, and it's just going to keep putting on new frames at its rate. It doesn't care if you're caught up or not. So if your process that's supposed to be processing those frames gets behind, you're going to stop. You're going to first of all start being laggy, so you'll be late in your decision making, and then you'll start dropping frames, so that you end up ignoring potentially important frames. The longer you're processing, the more likely you are to run into that problem. One solution is to slow down the source of information, so slow down the camera, but now you're by design less responsive and get less information into the system. So it's really quite helpful to have efficient vision processing algorithms so that the system can run in real time.
Cameras are very expensive, computationally, because you're processing so many pixels. So sometimes you gotta ask if you need a camera at all. Anyways, let's move on to apo-tag detection.
If that is the case, can you reduce the quality of the image
Yes.
and then that makes it possible?
Yeah. OpenCV has inbuilt functions to resize images to lower quality if you need.
And I would be more specific to lower pixel count.
Yeah.
Quality can be different things.
Alright. I have an apo-tag here. So an apo-tag is a family of Aruco markers. Sorry, it's part of the Aruco marker family. It's just like QR codes, but like much easier to detect because it contains so much less information. So for your major project, if you want places of significance, like a starting point or like a place of interest, you probably want to mark it with an Aruco marker. that's just one way. You can use like color detection as well, but I'm gonna go do an Aruco marker. So let's try to detect this. OpenCV has a header file called aruco.hpp. That's what that header file is. So I don't know why it's giving me squiggly lines, but we're gonna move past that. Let's get rid of this. Okay. So to detect an April tag, you have 4 main steps. You gotta get a predefined dictionary for the Aruco family. So Aruco markers have different families. Actually, I'm not gonna go through that, but there's a different number of families, and you gotta be specific on which family you use. My specific one is tag 36H11 or something like that. So we gotta specify that. So that's predefined dictionary. Then you have to create a detector object that does the detecting for you, so that you don't have to write in the code. You create the object, you run it, right? So create a detector object, then you detect, then you can like draw on it to know that, oh, it's there. So that's your 4 main steps. Get a predefined dictionary, create a detector, actually run the detector, and then draw whatever you want on it. Right? So let's start with getting the predefined dictionary. Oh, I am not indented properly. So this is a syntax. I wouldn't, don't question it. Just go with the flow. So we create the dictionary here. Actually, I'm lazy. I'm just gonna copy paste this. If it ever comes up. So, I can't even tell if that got selected or not. Did I get selected? This is gonna be a mystery. Oh, it did. Okay. Alright. This is the first step I mentioned. Create the dictionary, and you have to define what April tag you're using. So this is where you define it. You can search out what other family members there are based on what type you're using. This is the second step I mentioned. You create the actual detector object. So it's called detector parameters. You create it, right? So when you detect an April tag, there are 3 things that you get. You get the corners of the marker, and it has an actual orientation. You don't just get corner, 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 corner. You actually get top left, top right, because that's useful orientation. So you gotta keep track of marker corners. There's also rejected candidates. You will never use them, but the function definition requires you to have the rejected candidates from the image. And the last one is marker ID. So every April tag you generate has its own unique ID. So if you have several places in your maze that you want to go to, you want to create different tags with different IDs, right? And the detector object does this detection of the ID for you, right? So those 3 you gotta keep track of. Marker corners, rejected candidates, and the marker IDs. And then you run the detect markers function. All it takes is your image, everything we specified before, so your dictionary, your parameters, the 3 things you have to keep track of: corners, IDs, rejected candidates, right? And then it goes into an output image. So in OpenCV, CV ::mat is an image, right? So we've detected it, and then if we want to draw on it, we have CV draw detected markers. Just takes an output image and then takes the corners and the IDs. We don't care about the rejected because it has no place in the image. And then I do CV imshow and wait key again. So let's see if this compiles. Whilst that happens, any questions so far with this? Ruby first, I guess.
I was wondering, this is also like a ROS April tag kind of learn package that you can.
Yes.
Are we allowed to use that in use something?
I believe you are allowed to use that. I should have mentioned that before. There is an APOTAG node with ROS.
What considerations come up when you're deciding if you should use it or not? Instead of just, am I allowed to use this? Like, what are the considerations?
I guess probably have less like control over some code.
Why?
I might understand as well.
That's a good point. Doesn't sound like a nail in the coffin by any means, so I'll go ahead and use it. But yeah, please try to think about why would a particular thing be allowed or not.
I personally have not used the APOTAG ROS package before. Had a brief look. I'd be interested to take a deeper look, but it looks like it does a lot of things with APOTAGs. But I would still, even if I knew it, I would still prefer normal OpenCV because it's just so much more versatile, right? You could go into a workplace which doesn't use ROS but still use OpenCV, right? Your skills can come in here. The skills could come in handy. Aaron?
In the Aruco family, are they all tags or is it
There's multiple tags. Let's just... There's so many. These are all the different... Whoops. I've lost it. Here, these are all the different types of Aruco markers that you can get. This one is the one I'm using, the one in the last place. So yeah. Cool. Did I source it? I have not. Hey. Now let's run this again. Okay. This better work or I'm just gonna embarrass myself. Look, there we go. The lighting's a bit bad, so you can't see, but there's green lines around the border, and then the blue in the center should actually say the marker ID. You can't see it, but it says ID equals 0. And then the bottom right corner is red, marked with a red circle. So now you could be going somewhere in a maze, right? You don't see anything, you don't see anything, and then suddenly you're like, boom, yeah, that's my future ex-wife's house, where I'm supposed to be. And then you're set. Alright, that was the main thing I wanted to show. That's probably it. I have color detection prepared, but I'm not gonna do that. One, we're running out of time. Two, you should do something yourself. Anyways, any questions on that?
So is that, when it said ID equals 0, is that what that in that family, does that mean 0, or is 0 just the ID that the code allocated to it?
0 is the ID that was generated with this tag when you created it. So you can create your own APOTAGs, right? And then when you create your own APOTAGs, they will ask you to specify what's the ID of this. And then based on the ID, it will generate a pattern for you. I generated this with the ID 0. So it's not a matter of family, it's a matter of the actual ID that you gave it in the first place to create it. Anyone else?
So how do you generate the
Google it. Yeah. Yeah.
And what will you find?
Sorry?
And what will you find when you Google it?
OpenCV docs, documentation, not that great, but it's good enough.
Do you have a favorite tool that you use when time to print up your Aruco markers?
Not really. No. I generated this like 2 years ago and I keep using this. It's like my make file. I've been using the same make file since Mechatronics 1. I just keep copying over it. Did you have a question? Yeah.
You said you could use color detection as well. Is it in the final, like the major project, is the marking different depending on what method you use?
What was the
So in the major project, if I use the tag or if I use color detection, would the marking still be the same, like same?
Oh, grading.
Yeah.
Yeah, it's a question of, if you look at the criteria, how did it affect the design process? So for me, having an Aruco marker that's off the shelf that just works, and having a color blob detector off the shelf that just works is about the same level of effort. But it's also about functionality. And for me, getting a color blob detector to actually work in practice in a lab where the light changes versus getting an Aruco marker detector to work reliably, the blob detector is harder to get working. So should that be more or fewer grades? Good question. I'll say if your functionality suffers and you can't demonstrate what you wanted to, then your grade will go down because of that. So keep that in mind.
The process isn't that hard though. You have to work with the HSV color space, just specify your upper and lower bound for your hue, saturation, and value, and you just put a threshold on it, and then you can create a mask.
If you're interested in it, ask Kit at any time, we'll step you through it.
I guess, yeah. This code actually didn't compile. Well, it did, but it got a runtime error because I have OpenCV 4 instead of 3. So I wrote one in Python to show the exact same effect. It works, except I've lost my yellow duck. So I don't know where it is.
Oh, no.
Yeah, has anyone seen my duck?
Oh, well spotted.
How did you see it?
Wow.
Sorry.
How did you see it?
Is it actually? I'll say it.
Well calibrated duck.
Thanks. I'll just show this. I won't go through this, but I will show how it works. Oh, whoopsies. Oh, it's because my ROS node is still launched.
Yeah, video busy.
Yeah. It's my yellow duck. The eyes. Oh, it did appear. It does appear. Yeah, there we go. I've also, fun fact, I've also ordered 48 more ducks, and it comes in more colors this time. But yeah, that's it. I'm gonna end it there.
So thank you, Kit. How many more work periods do you have before your demo sessions? One. Okay. Good heads up. So please, yeah, it's great to see the project ones. I look forward to grading them. And please, yeah, do make good use of Kit's time while you're here. And Canvas, we'll get on there and ask questions. Off to work for you.